Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. So also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my live classes which are absolutely free of charges and are going to help you to crack the exams related to physical science. Okay, so this is the lecture of quantum mechanics in which we are going to discuss finite depth potential well. Okay, so I will start now. Meanwhile, just let me check around. Okay. I would request, yes, I'm audible. Okay. So Vx equal to minus V naught when mod x less equal to A. Okay. That is uh, x is between A2 plus A. Okay. Or the value is 0 when mod x greater equal to A. Okay. So this is the definition. We have defined the potential well. That is finite depth potential well. Okay, finite depth potential well. So I will draw the figure. This is like this. Okay, straight line, guys. Okay, so this is minus A, this is A, this height is V naught. Okay, V naught, and this is the this is A. Okay, this is 0. Okay, so this is a finite depth potential well, and then A. Okay, and 0 when mod x is greater than A. Okay, well, so this is about potential well. Now we'll define energy for bound state. We're talking about bound state. Okay, for bound state energy E is going to be minus mod E. Okay, energy is going to be minus mod E. Region 1, right? For region 1, so if we talk about this, this is region 1, this is region 2, this is region 3rd. Okay, for region 1 you can see potential is 0, this V. Okay, V naught 0, this is minus V naught, guys. Okay, so potential is 0. So for region first, I have already uh, taught this thing in my previous lectures, right? Region first, region second, and the Schrodinger equation and wave functions in finite well potential step, and rectangular potential barrier. Okay, so now it will be easy for you to understand. For region 1, uh, V is going to be 0, right? So the Schrodinger equation is going to be d2 psi over dx square plus 2m E upon h cut square equal to 0, right? So this is going to be d2 psi upon dx square, uh, this is psi, okay, square plus alpha square square. Okay, here we'll write the value of this as well. Okay, so value of E is minus mod E. Okay, so then if you put this, So this value is going to be minus 2m mod E upon h cut square psi equal to 0. Okay, so it is going to be d2 psi over dx square minus alpha square. Okay, psi, these are for region 1, so we can write psi 1. Okay, psi 1, psi 1, psi 1, psi 1. Okay, so this is going to be alpha psi 1 equal to 0, where value of alpha equal to alpha value is root this is 2m mod E upon h cut square. Okay, 2m mod E upon h cut square. So now the wave function is going to be, for this wave function is going to be psi 1 equal to a e to the power alpha x, okay, plus b e to the power minus alpha x. Okay, e to the power alpha x plus b e to the power minus alpha x. Okay, so at x equal to minus infinity, okay, psi 1 minus infinity at equal to minus equal to 0, will put the value. So this is going to be a e to the power minus alpha x, means x equal to infinity, right, minus alpha into infinity minus infinity minus minus plus. Okay, minus infinity means minus minus plus. The minus is already there, right? So this is minus alpha infinity, we can write minus infinity. Okay, minus infinity, and then this plus b into e to the power minus minus plus plus infinity, right, x equal to 0. Alpha into infinity is infinity, right, plus infinity equal to 0. So this implies this value is 0. E to the power minus infinity is 0, right? So this means an e to the power plus infinity cannot be 0, right? It means b equal to 0. Okay, so b equal to 0 means then wave function, this first is going to be b is 0, right? So a e to the power alpha x, right? Because here uh, because this b is 0, it's constant, right? That b is 0. So you know how to solve this differential equation, right? Very simple. Okay, so this is the equation number 1. Okay, now for region 2, for region 2, okay, or for region 2nd, we'll check. For region 2nd, this region, right, for this region. Okay, so for this region, is the height, right, for this region, that is okay, for this region vx is there, vx is minus v naught. Okay, for region 2, vx equal to minus v naught. Okay, now we'll write the Schrodinger equation for it. Okay, so it is going to be d2 psi 2 upon dx square plus 2m upon h cut square. Okay, h cut square into e minus v equal to 0. Now we'll put the value. So d2 psi 2 upon dx square plus 2m upon h cut square e minus 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 plus e plus v naught equal to 0, right? And value of e also will put, value of e is minus mod e. Okay, minus mod e, since this is, we know value of e is given minus mod e. Okay, I've defined here. Okay, have I or not? Yes, this bound distance energy is minus mod e. Okay, so this is going to be like this. So then equation is going to be d2 psi 2 d2 psi 2 into psi 2 upon dx square minus 2m v naught mod e, sorry, my apology, this is going to be minus 2m upon h cut square v naught minus mod e equal to 0. Okay, so next this is going to be, this will okay, so this is plus. Okay, so this v naught minus mod e. Okay, so this sign will be plus. Okay, so here where value of k is going to be, or okay, we'll write next page. So this equation is going to be d2 psi 2 upon dx square plus k square psi equal to 0, where value of k equal to root 2m upon h cut square into v naught minus mod e. Okay, v naught minus mod e. Okay, 2m upon h cut square v naught minus mod e. Okay, so this is the value of k. Okay, this is psi 2, guys. Here this is psi 2, psi 2. Psi 2 psi 2 psi 2 equal to 0 equal to 0. Psi 2 equal to 0, right? So this is the one. So now we'll find the wave function. So psi 2 is going to be, this is c cos, c cos kx plus d sine kx, right? This is the wave function, this is the value of k. Similarly for region third. Okay, for region third it is going to be psi, for this region, guys, I'll show you for this region. Okay, for this region, for the region third it is going to be psi 3. This is the wave function. Psi 3 is going to be uh, f e to the power alpha x plus d f g e to the power minus alpha x. Okay, and here condition at x equal to infinity. So at x infinity, psi third at infinity is going to be 0, or from there, right? So this value is 0 plus, and this is minus infinity, right? So here this is positive value, right? So it means f is 0, so psi third equation, psi third, the wave function for third region is going to be g e to the power minus alpha x, because f equal to 0, right, guys? So let me just check. So g e to the power minus alpha x. Okay, so these are the three wave functions for three regions. Okay, so now since potential is symmetric, okay, since potential is symmetric, symmetric. Okay, so for the wave function for even state, okay, for even state wave function are going to be, for region 1 it is going to be a e to the power alpha x, and for region 2 it is going to be c cos kx, and for region 3rd it's going to be g e to the power minus alpha x, Now for odd state, for odd state psi 1 is going to be a e to the power alpha x, psi 2 is going to be d e to d sin x, okay, d sin kx, and psi 3 is going to be, this is g e to the power minus alpha x, okay, for odd state, because for even this one, for even, right, this, because this for second region this is the wave type, right, this one, this is the wave, right, this one. So this is for even, this is for odd, and these are for odd and even both, okay. So that's why for region first psi 1 equal to a e to the power alpha x, for region second c e to the power kx, and for region third it is psi 3 equal to g e to the power minus alpha x. For odd state, psi 1 and psi 3 are same, but psi 2 is d sin kx, okay. These are for even and odd state, because this potential is symmetric, right. Okay, next point is, so I'll make a figure for it as well, okay. So this is the depth well potential. Okay, so these are the states. So the graph for this potential well is going to be minus a, this is a, okay, this is origin, line passing through origin, okay. Okay, this is 0, and if you draw the graph, this is n equal to 1, and this is n equal to 2, okay. So if you draw the graph, this is going to be like this, and this is going to be like this, and this is, okay. So this is the graph, region first, second, third, okay. This is first, second, and third, okay. So this is the graph. Now for wave function, okay. Okay, so now this is very important, guys, so you will get questions from here, okay. So I will solve one question for it as well, okay. So this is number of bound states, okay. So number of bound state number of bound states depends on number of bound states depends on V naught and A is the width of L, okay. V naught and A. So number of bound state depends on V naught and A, okay. So I will tell you how. So here before that I'll write ground state, okay. If there's a ground state, okay, so there would be even number of bound state, okay, even number of bound state, or even bound state, okay. For ground state, even number of bound states. Okay, if it is ground state, then so there would be even number of bound states. Okay, for ground state means n equal to 1. Similarly, for excited state, first 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 excited state, there would be odd number of bound state. Okay, odd number of bound states. And if first state means first excited state means n equal to 2. Okay, number third, second excited state. For second excited state, there would be even number of bound state. Okay, even number of, very important guys. Okay, even number of bound state, even number of bound state. So that is n equal to 3. Second excited state means n equal to 3. Number 4, for third excited state, obviously odd number of bound state, odd number of bound state, odd number of bound states. Okay, or n equal to, or for a third excited state, n equal to 4. Okay, so if it is ground state, then there would be even number of bound state if first excited state, odd number of bound state second, even third. Okay, and these are the, for n equal to 1 is ground, n equal to is first, n equal to 3 is second excited state, or n equal to 4 is third excited state. Okay, well, now I'm going to write very important formula. We'll solve questions. Okay, so this is number of bound state. Okay, so number of bound state, so this is even number of bound state, this is denoted by NE. Okay, number of even bound state, you can say number of even bound state, even bound, number of even bound states, number of even bound states, and that is denoted by NE, even number of bound state. Okay, even number of bound state or number of even bound states. Okay, number of even bound states. So before that, the gamma square value of gamma square is, this is 2m v naught a square upon h cut square. Okay, 2m v naught a square upon h cut square. Okay, so very important, this one, very important. Okay, so so for even number of bound state, okay, how we will find this? NE, okay, NE minus 1 pi, which is between gamma, okay, and greater equal to NE, okay, NE pi, NE pi. Okay, if you have to find number of even bound state, the formula is this number. So the value of gamma will lies between NE minus 1 pi to the NE pi. Okay, this is very important formula. Okay, next, for odd number of bound state, so number of odd bound state. Okay, number of odd bound state, number of odd bound states. Okay, number of odd bound states is denoted by any odd, right? And the formula for it, to find how, if you want to find the odd number of bound state, and the formula is this one, n NO, that is number of odd bound state. NO minus half. NO minus half pi is between, gamma is between NO minus half pi to NO plus half pi. Okay, so NO, that is odd number of bound states, minus half pi, and gamma is between N naught plus half pi. N naught plus half pi. Okay, this one. And so if we generally want to find the number of bound state and we don't know the odd or even, right? In general case, okay, in general we can say in general or general case, in general, so the formula for number of bound state is going to be n minus 1 pi by 2, and gamma is between n minus 1 pi by 2 to n pi by 2. Okay, so n is the number of bound state. We don't know whether it's even or odd, so it is in general case n minus 1 pi by 2, gamma is between n minus 1 pi by 2 to n pi by 2. Okay, n minus 1 pi by 2 to n pi by 2. Okay, okay, so now I will solve one question, then it will be, your doubts will get clear. Okay, okay, question is, okay, so this is, question is, there are three bound states. There are three bound states. There are three bound states of a particle. There are three bound states of a particle. So particle has three bound states. Okay, of a particle. There are three bound states of a particle of mass m. In 1D potential, or we can say in 1D finite depth potential. Okay, 1D finite depth potential. Okay, depth potential well. Okay, so there are three bound states of a particle of mass m in 1D finite depth potential well. Okay, finite depth potential well. Okay, so now what you need to find out, depth of the potential you need to find out. Okay, so depth of potential, that is V naught, you need to find out. Okay, so we'll solve it, we'll use the formula. Okay, so there are three bound states, of a particle of mass m in 1D finite depth potential, which is in 1D finite depth potential. So depth of the potential. Okay, this is the one. So like this, particle is in 1D finite box, potential well, mass, right here is. So we need to find out this height, that is V naught. Okay, this we need to find out. Okay, so there's a formula for in general case, right, how to find number of bound state. I just explained. So that is n minus pi, sorry, n minus 1, n bound state is n minus 1 pi, my apology, n minus 1. Okay, n minus 1 pi by 2, that is gamma, is between n minus 1 pi by 2 to n pi by 2, right, this formula. gamma n minus n gamma is between n minus 1 pi by 2 to n by n pi by 2. Okay, n pi by 2. That's we'll put the value. So n is 3, right? And the number of states are 3. 3 minus 1 pi by 2 to gamma is equal to 3 pi by 2, or it is going to be 2 will get cancelled. Okay, so 2 this side 2 pi by 2 and gamma 3 pi by 2. So we know the value of gamma square, right? We know value of gamma square is m v naught upon h cut square a square. Okay, this one 2m v naught gamma square value is 2m v naught a square upon h cut square, right? So this is 2m v naught a square upon h cut square. Okay, a is the width of the potential value, right? Okay, so here in question potential value is also given, guys. Figure is given. I have not written, but I will write it. So figure is given here. I'm making this figure. So this is like this. This depth is v naught. Okay, v naught. This is this value is this width is a, guys, and this value is minus a by 2, and this is plus a by 2. Okay, and this is line passing through origin. Okay, so this is origin, right? This is origin. So you can say it's minus a by 2 and a by 2. Okay, this one minus a by 2 and a by 2. Okay, so here so this is going to be this 2. So the value of gamma square is 2m v naught a square upon h cut square. Okay, well, now we'll put the value. So we know the value of gamma square, so we'll square in left hand side, right hand side, right? We'll square it, so it is going to be 2 will get cancelled. Okay, this is going to be pi square into gamma square, and it is going to be 3 3 is 9. We have square on all sides. Okay, so this is 9 pi square by 2. Okay, so now pi square is between, we'll put the value of gamma 2m v naught upon h cut square. A square is a by 2, guys. Okay, this is value of a is a by 2 here, a by 2. So this is going to be a by 2. Okay, this is for a by 2, right? And the potential here I have explained, this one for a. Okay, this is for a. And here in this question, this is a by 2, a by 2. Okay, so this is going to be v naught h cut square between 9 pi square by 2. Now we'll put these two, this side and this side, and v naught will remain in between. So this is going to be 2 pi square h cut square upon ma square, and this is v naught is going to be between this one 9 pi square h cut square, 9 pi square h cut square upon 2 ma square. Okay, so the value of so we need to find out value of v naught, depth of potential, right? So from here, depth of potential is lies between 2 pi square h cut square upon ma square to between 2 pi square h cut square upon ma square and 9 pi square h cut square upon 2 ma square. So v lies there. Okay, Here what we have done, we have this value we have taken in left hand side, also in right hand side, okay, cross multiplied. So only v is remaining here, and then this is the value. So v naught value is between this value, and this is the answer, guys. Okay, so a very good question, guys. So you can get these questions are this question is asked in the physical science exam. Okay, different exams of physical sciences. Okay, so okay, guys. Well, so guys, just give me 1 minute. Okay, guys. So before ending the class, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures, which are absolutely free of charges and are going to help the students to crack the exams related to physical science. Okay, okay, guys. Thank you. Bye now. After this class, I am going to take mathematical physics class. Okay, just after this class. Okay, bye, guys.